We're going to keep this video super short and super sweet. One of the things, I'm just going to give you the formula. I'm not even going to prove it because it's on your reference sheet, and I don't really think you guys care that much. And then the other thing, I'm going to prove it really quickly, and then we're going to do a couple things with it, and then we will be done. Alright, so the super short thing first is that we have so far done sum and difference formulas for sine and for cosine, but we also have them for tangent. So, and that's the new thing. So, we have a formula for the tangent of angle A plus B. This one's a little more complicated, but like I said, it is on your formula sheet that you get for the exam. And this is going to be the tangent of A plus the tangent of B divided by 1 minus tangent A times tangent B. Okay? I guess the nice thing about this one is that it just involves tangents. Alright, and if it's a plus sign, it's going to be a plus in the numerator and then the opposite in the denominator. And then it's going to be the exact same thing for the tangent of A minus B. That's going to be the tangent of A minus the tangent of B. Alright, the exact same sign. And then 1 plus tangent A, tangent B. So it's got to have the same sign in the numerator that you started with, and then the opposite sign in the denominator. I'm not going to do any examples, because I think we kind of get the gist of how we do problems like this, but we will do some in class next time. The thing that I do want to prove is something for the area of the triangle. Okay, so just like for the law of cosines, that was using cosine of an included angle to find all the side lengths of a triangle. It didn't have to be a right triangle. So that was kind of using trig to help us find stuff for triangles that weren't right. So we had the Pythagorean theorem for right triangles, and then we stepped it up a notch. Now we have the law of cosine that works for any triangle. So if we remember the area of the triangle that we know so far, that is 1/2 base times height. Okay, so I'm going to draw this triangle, and I want you guys to draw this as well. Okay, notice that this is not a right triangle, and here is going to be A, here is going to be B, here is going to be C. So then I can go ahead and label where my little letters are. So across from the big A is side little a, across from the big B is the side with the little b, and then the same for C. So looking at this right now, if I wanted to find the area of this triangle, I have my base, that's A, but I don't have the height yet. All right, we would have to drop in this perpendicular, because heights are altitudes. They have to form a right angle, and then that would be my height, my h. So specifically for this triangle, if I did the area, that would be 1/2 times the base, but in this case my base is of little a times h, which is the height. All right, but notice, and we do this a lot, anytime we have a triangle that's not right, we generally break it into tiny right triangles, which is what we did right here. If I look at this tiny right triangle right here, I know that the hypotenuse is equal to b, and the opposite side is h. All right, so I know the opposite side is h, and I know the hypotenuse in here is b. So if you think about it, if I use SOHCAHTOA, because I can, it's a right triangle, in this one on the left, I've got this angle C, I have the opposite in the hypotenuse side. I know that the sine of C is going to equal h over b, if I could write my letters. Which I could multiply both sides by b, and I get that b times the sine. Wow, I did not write today. Woo. And I get that B times the sine of C is equal to H. Which is awesome because now I can take this and I can come over here and I can plug it in for H. So I can do a little substitution. So really I have that the area of this triangle is equal to 1/2 A and then whatever H was, which was B times the sine of angle C. And that is our new area of a triangle formula. Okay, in this case, I don't need to drop in a perpendicular and find that. It does not matter if my triangle is right or if I know the altitude. Now, as long as I have some triangle, and I've got A, B, and C, here's side A, side B, side C, as long as I have two sides and the angle in between them, I can find the area. Okay, it's very similar to the law of cosines. Remember, for the law of cosines, we had to have two sides and the angle in between, and that's what would tell us the angle across. I still need to have two sides and the angle in between, but now I can use area, or I can find area. And lucky for you guys, this is also provided to you on the reference sheet for the Regents exam, so you do not have to memorize it. Yeah, but let's see how I'm doing on time. Oh, let's do one, maybe two examples, and then we will be good. Next. Okay. So let's say in triangle ABC, we will let A equal 6, B equal 8, and we will have the sine of angle C equal 1/4. Horrible equal sign. Find the area. So it's not totally necessary, but I still think it's good to draw the picture. So here's my triangle. Notice it's not very pretty, but it's okay. This will be A. This will be B. I don't know anything about little c, but I know that the sine of c is 1/4, and here's my angle c. So this satisfies what I need to use this area of the triangle formula. I have two sides, specifically I have A and B, and I have the angle in between. Okay, so to find the area, it's going to be 1/2 AB times the sine of C. So I'm just going to plug in. That's 1/2. A is 6, B is 8. The sine of C is 1/4. So that's going to be 1/2 times 6 is 3, and 8 times 1/4 is 2. So the answer is 6. There we go. So this triangle has an area of 6 units. Now notice we also could have used the law of cosines to find C. So I'll kind of do that down here. Because I have two sides and the angle in between. So this would give me, fix that. This picture would give me C squared equals A squared plus B squared minus 2AB times the cosine of C. All right, now they gave me the sine of C, but I could definitely use my Pythagorean identity, sine squared plus cosine squared. I could find the cosine of C. All right, so we can do a lot with non-right triangles now. Let's do one more example. Here we go. Dose. Find the area of triangle ABC if the measure of angle A is equal to 30. What is up? The measure of angle A, there we go, B is equal to 10, and C is equal to 5. Okay, so let's draw a picture here. So here's A, B, C. This would be little a, which I don't know anything about. Here's B, which would be 10. And here's C, which would be 5. Now, they gave me angle A, which is perfect because angle A is included between the two sides that I know. So here's one side, here's the other side, A is in the middle. So this satisfies what I need in order to use the area. Alright, so this is going to be 1/2. Now, I'm not using A and B. In this case, I'm using B and C. And I need the cosine, I'm sorry, not cosine, oops, the sine of A. Okay, so you should always be using the 3 letters of your triangle, A, B, and C in some way. Alright, in general, we kind of have them going in order. But notice, if I'm using A and B as my side lengths, I have to use C for my angle. In this case, I'm using B and C for my side lengths, so I have to use A as my angle. Very similar to how we remember things for the law of cosines. So now let's just plug in. So this is going to be 1/2, B is 10, C is 5, and now they didn't give me the sine of A, they just gave me A, so I actually need to find out the sine of 30. Okay, well, lucky for us, 30 is one of those special right triangles we know. We've got 30, 60, across from the 30 is your x, 2x, x radical 3. And sine is opposite over hypotenuse, so opposite over hypotenuse, that's going to be 1/2. So this is going to be 1/2 times 10 times 5 times another 1/2, which, let's see, 1/2 times 10, that's 5. 5 times 5, that's 25. And 20, well, I'm just going to write that as 25 over 2. Which you could say is like 12.5, but we all know how I feel about decimals. Okay, but that is it. Alright, so just like law of cosines, as long as we know what's what, we're just plugging and chugging it. Alright, and I'm done. See you guys next class.